Traditional automakers spent decades building their factories according to the same principle. Tesla decided to throw that principle in the trash, and the industry still hasn't recovered from the shock. But the most unexpected part here isn't what the company got right, it's that it first got something catastrophically wrong, and it was precisely that failure that ultimately led to the revolution. For more than 100 years, the global auto industry lived by one rule: break the car down into thousands of parts. Assemble each one separately, then weld, bolt, and inspect until a finished vehicle rolls off the line. Toyota, Volkswagen, Ford, General Motors, they all followed this formula. It had been refined by generations of engineers, and no one seriously thought about changing it. No one, except for one person who asked a question others considered pointless. If dozens of small parts end up forming one large structure anyway, why make them separately in the first place? Why not create the whole section at once, as a single piece? That very question kicked off what's now called the biggest manufacturing breakthrough in Tesla's history. The answer was the Gigapress, a giant casting machine that takes molten aluminum and turns it into one massive single piece in a single cycle. Where dozens of stamped panels and hundreds of welds used to be required, there's now one monolithic component. These machines produce clamping forces of 6,000 to 9,000 tons, and the next generation is expected to reach a fundamentally different level of power. The effect turned out to go far beyond a single part. At the Texas factory, Tesla was using more than 1,000 robotic arms just to weld frames. After the Gigapress was introduced, nearly half of them became unnecessary. Fewer parts means fewer failure points, fewer production errors, and simpler logistics. Cars started coming off the line faster, and the cost of producing them began to drop. But here's the important thing to understand: the Gigapress isn't the end point. It's only the first step. Tesla is going further and getting ready to challenge another rule the auto industry had taken for granted. The traditional assembly line is one long sequential line. Each new component is added one after another, and the next stage doesn't start until the previous one is finished. A bottleneck anywhere along the line stops the entire production process. Tesla wants to break that logic completely. The new system, which the company calls the unboxed process, involves splitting the car into 6 major modules. The front of the body is assembled in one place, the rear in another, the battery pack on a separate line, and the interior is installed in parallel at the same time as all the other sections. All the parts move independently of one another and only come together at the final stage. According to Tesla's calculations, this system can cut production costs in half, reduce the factory floor space needed by almost 40%, and substantially improve overall production efficiency. The 50% cost reduction figure is the key number. If it holds up in practice, this won't be about a new electric car. It will be about a new era in car manufacturing. The first car meant to embody this whole philosophy will be the Cybercab. According to statements from Elon Musk, the goal is to reach a production cost of around $30,000 per unit, with further reductions expected as production scales up. Full-scale series production under the new system is planned for around 2027. While the factory is rolling out the new casting methods, what many engineers consider its true heart keeps running inside it, the body welding shop. Here, hundreds of robotic arms work around the clock without stopping. Every few seconds, thousands of welds are completed, and another car frame takes shape. Tesla doesn't limit itself to a single joining method. Resistance spot welding secures the body at the most heavily loaded points. Where maximum precision is needed, laser welding is used, producing a cleaner, stronger seam. On top of that, high-strength structural adhesives borrowed from the aerospace industry are applied. They bond the major sections together, significantly increase the body's torsional rigidity, and reduce vibration. It's precisely this combination of technologies that explains why Tesla vehicles consistently earn some of the highest crash test scores. A stiffer passenger cell absorbs and redistributes impact energy better. But there's something robots do better than any human, and it isn't speed, it's repeatability. A skilled worker can do excellent work, but after many hours of monotonous operations, micro-deviations are inevitable. A robot performs the same movement thousands of times in a row with identical precision. Every body that comes out of the welding shop meets the exact same standard, no exceptions. The next stage is the paint shop, and here everything is different. It's arguably the most demanding place in the entire factory. A single microscopic speck of dust on the metal surface can ruin the final finish and send the whole body back for rework. That's why temperature, humidity, and air cleanliness are controlled with exceptional care at every stage. First, the body goes through deep cleaning, removing even the smallest traces of dust, grease, and grime left over from welding. Then comes a stage few people outside the industry know about: electrophoretic deposition, or e-coating. The entire body is submerged in a special chemical bath, and the anti-corrosion coating penetrates every metal surface, including the internal cavities that no sprayer could ever reach. This is the first and main barrier against moisture, road salt, and rust for years to come. After the primer, robotic systems apply the color coat, then a clear protective top coat. The thickness of each layer is automatically controlled, so the finish comes out perfectly even. The body is sent into an oven where, at precisely calibrated temperatures, all the layers fuse into a single solid coating. Here's an interesting detail. The paint shop is one of the few places where several Tesla models run on the same line. Only after painting do the bodies split off onto separate final assembly lines. But the Cybercab may skip this stage entirely. Tesla is planning to build the color and protective coating directly into the large casting, even before assembly. If that works, an entire production department that the auto industry has maintained for decades will become unnecessary. And this is a good moment to recall the very failure that started it all. In 2018, during the Model 3 production ramp-up, Tesla tried to automate literally everything. The goal was 5,000 cars a week. Reality turned out differently. Robots couldn't handle flexible materials and complex wiring. The line kept stopping over and over, and production ground to a halt. Musk later admitted the mistake outright. Excessive automation at Tesla was a mistake. Humans are underrated. That painful experience completely changed the company's approach. Today, Tesla isn't aiming for maximum automation. It's aiming for maximum efficiency. Robots do what they're objectively better at than humans: precision, repeatability, speed on standard operations. Humans stay where flexibility and adaptability are needed. The two work together, and it's precisely this combination that makes Tesla's production system what it is today. The electric car race stopped being a competition over range or acceleration a long time ago. The real battle is playing out inside the factory walls. Whoever learns to build a car cheaper than anyone else gets the chance to cut prices, capture market share, and pour the freed-up resources into the next generation of technology. Tesla has already shown this logic in action, cutting prices in global markets and forcing competitors to react, squeezing their own margins. If the new production system delivers on its promises, the gap between Tesla and the traditional automakers could end up so wide it can no longer be closed. If you found this useful, hit like, subscribe to the channel, and turn on notifications. There are still plenty of stories ahead about technologies that are changing the world right now. See you in the next episode.